Okay, guys, don't be scared. I go away and I come back and there's this scary looking formula on the board. It's not hard, and I will simplify this for you. So EIGRP uses feasible distance as its metric. And what is feasible distance defined as? Well, feasible distance is defined in this formula. So K1 into bandwidth, and I will explain what K is, plus K2 into bandwidth over 256 minus the load on the link, or the current traffic on the link, plus K3 into delay, the delay of the link, the delay a packet will incur while traversing that link, multiplied by K5 divided by K4 into reliability, the reliability of the link being how many times in the past hour or so this link has failed and come back up. The whole thing multiplied or scaled up to by 256. Now, the bandwidth for EIGRP is actually 10 to the power 7 divided by the lowest bandwidth between your current position and the destination, between the source and the destination. The EIGRP delay is defined as the sum of all delays between source and destination in units of tens of microseconds. This little u stands for micro. So whatever the total delay is, we'll simply divide it by 10 because it has to be in units of tens of microseconds. By default, these k values, K1 and K3 are 1, and K2, 4, and 5 are set to 0 by default. If K5 is 0, then you ignore this half of the formula, which is weird. It doesn't work like that in mathematics, but it's Cisco's protocol, Cisco's rules. So if K5 is 0, you ignore this half of the formula. K values range between 0 and 255. Now, what exactly is a K value? K is nothing but a weight. It's a knob that you can turn. So by default, K1 and K3 are 1, and everything else is set to 0. What if I wanted EIGRP to also consider the load of the link while making its calculations to find which the best route is with the lowest feasible distance? Then I might want to increase the K2 value from 0 to maybe 5. I wanted to consider the load on the link a little bit more than bandwidth. Or I wanted it to consider the load on the link a lot more than bandwidth. I can set this to 255, K2 value to 255. What if I want EIGRP to consider only the delay of the link and not the bandwidth? Well, I can set K1 to 0, all of the K values to 0, and I can set K3, which is multiplied by delay, to a high number, or just 1. If I want EIGRP to only consider bandwidth while making its calculation, I can set all of the K values to 0, and I can just set K1 to the number 1 or a higher value. Now, as I said, K1 and K3 are 1 by default, and every other K value is 0. Let's see what happens to our formula once we set the K values to 0. So K2, 4, and 5 are 0. So if K2 is 0, 0 into something is 0. So this goes to 0. Okay, this whole portion goes to 0. If K5 is 0, we ignore this side of the formula. So the formula reduces down to K1 is 1. Anything multiplied by 1 is the same number. So bandwidth plus K3 is 1. So anything multiplied by 1 again is 1. Delay, whole thing multiplied by 256. The feasible distance formula reduces down to bandwidth plus delay if default values are being used, multiplied by 256, scaled up by 256. This concludes the metric portion or the feasible distance portion of the lecture.